All right, for this bell work, we're gonna solve it just like we have been doing in the past here, especially last time we were doing these two-steppers. So we should require only two principles of equality to solve this. So I'm gonna bring the inequality down just because I know I'm gonna be using the subtraction principle of equality to zero out this plus 6. So that's 6 minus 6, which is going to be 0 just as we planned. But if I do it on one side, I gotta do the other side as well. Okay, so that's gonna be 0. Which allows me then to isolate the y's in this case, the negative 4y's. Like I said, we're using the subtraction principle of equality, so the greater than symbol just comes down. 34 minus 6, that though would be 28, positive 28. Okay, next up, now that we have this new inequality, the last thing I need here is to have a 1y, and the rest of it can be worked with as we need to, in this case, divide. So yeah, that's what we got. Negative 4, we need to make it a 1. And it's a coefficient of y, but how do we make it a 1? Well, just take it and you're going to divide it by itself, okay? So negative 4, that'd be divided by negative 4, because anything divided by itself is 1. But again, if you do this to one side, you're going to have to do it to the other side as well. Now here we notice that we divided both sides by negative, which means that we're going to drop this inequality, but since we divided both sides by negative, it will flip the inequality this way. Okay, so I end up with 1y is less than 28 divided by negative 4, which would then be negative 7. Okay, and this is the inequality that we're looking for here in the end. The objective is a little bit different. I can solve and graph inequalities. I'm going to add another one. Yeah, so not only will we have to be able to solve an inequality like we did in the bell work, we're going to have to be able to graph them as well. But then what we're going to do is write the inequalities from the graph. So it goes both ways. You can take the inequality and make the graph, but they're going to give us the graph, and then we'll make the inequality. So going back, we do have our principles of equality, which we've seen quite a bit of, not only in this unit, but in the previous unit. And we know if we ever use the addition or subtraction principles of equality, that we do these to make zeros. All right? And then if we look at multiplication and division principles of equality here, these are used to make, usually it's just the coefficient, a 1. Okay. And as it turns out as well, it usually is in this order. So that means that you'll make zeros first, just like we saw in the bell work, and then you'll make coefficients second. You make those ones, okay? Now at the bottom here, we see that there is one extra rule, which we have already seen from last time, and that is just that if you ever multiply or divide both sides. So that's a principle of equality, right? Either multiplication or division. If you ever multiply or divide both sides by a negative, then flip, there we go, the inequality. Okay? So again, that's only related to the multiplication and division principles of equality. All right, so going back, it says to distribute and combine like terms. We've only seen a little bit of this on the bell works. We shouldn't see any of these today. So using principles of equality to isolate the variable, that's talking about making zeros. And then when it says to divide by the coefficient, we've seen that it's possible to need to multiply by the denominators, and that is to make ones. Okay, so we are talking specifically about the coefficients there, but the same two properties there, or rules, or steps, are used with inequality as well, right? Using principles of equality to isolate the variable, that's making zeros, and then dividing by the coefficient, that's to make ones. And then if the coefficient is negative, then flip the inequality. That's just the same thing as, yeah, it's just the coefficient is negative, then flip the inequality. That means if you ever multiply or divide both sides by a negative, then you'll be looking to flip the inequality, just like we've seen. And again, that's kind of the X rule, which we saw on the bell work too. Okay, so on this one, let's go ahead and solve this one. We're not going to graph it yet. We'll get into that. But the first thing here that we're going to need to do is to isolate the variable. So that means that we're looking at the x over 4 there. So that means I would like to just be able to drop this as x over 4. Okay, so that minus 13 or negative 13 has to be zeroed out. So I'm just going to add 13 there. Okay, but again, if you do it on one side, you're going to have to do it on the other side. Now this is the addition principle of equality, so it is not going to flip the inequality. I still have a greater than or equal to symbol. But the good news here is that the negative 13 or minus 13 does zero out as planned. And then negative 8 plus 13 is going to be positive 5. Okay. Next up, what I would really like in the end here is to have just one x's, not x divided by 4 or x over 4. So how do you make that divide by 4 1? You got to multiply by 4. Okay, so that is multiply by x over 4. Again, that goes back to fraction multiplication stuff, which makes that a 1 right there, which is the same one I got there. It's just if you do it to one side, you got to do the other side. Okay, now this 4 that I'm multiplying both sides by is positive, which means that the inequality is just going to come down directly as greater than or equal to. Then you got 5 times 4, which is 20. Okay, and that is our inequality that it demonstrates all the values of x that would make this a true statement. How many values would make this original inequality true? There's actually an infinite number of values because starting at 20, anything bigger than 20, that's how this reads, x is greater than or equal to 20. 20 would make this a true statement because it would be equal, but anything bigger than 20 would work as well. If you replace x with 21, that would be bigger, all of that would be bigger than negative 8 or greater than. You could say 22 or 23. You could go as high as you want, 100, a million, maybe even a trillion. Put that value in as x, and you'll see that whatever you do with that divide by 4 minus 13, it's going to be bigger than negative 8, okay? So this is what this communicates as inequalities. But we're going to see these in a graphing form as well, which is a nice visual way to see what values of the variable would make the inequality a true statement. Okay, so this is the process. Now this last step right here, write in at least 3 numbers. Okay, so what that usually means is when we're doing this by hand, that they're just going to give us kind of a line like this one. It means that you're going to have to put your own 3 values in like this, all right? Now, along these lines, you have 4 different symbols, although they are related. So less than and greater than symbols. If we see these, then you're going to have an open circle at whatever value it is that we're comparing x with. Okay, so if I went in and I said, hey, look, let's compare x with, I don't know, 5, okay? In fact, let's make it less than 5. So on my number line, I'd say, see how I'm comparing directly x with 5? So for me, I would say I'm going to put 5 in the middle, 4 on the left, and then 6 on the right. Okay, so that's 3 values on my number line. But on this one, it's just x is less than 5. So that means that at 5 on my number line, I need to communicate that 5 would make the inequality false. And that's why we use an open circle. An open circle tells us that the value that the open circle is at is false. Okay, so open circle there, 5. Now if by chance we had the equal part of this inequality, then I would just fill in the circle. We'll call that a closed circle if it's filled in. Okay, so that gives us a circle. Now we got to indicate all the values on this number line that would make the inequality true. So I see x is less than 5. That means everything that's smaller than 5, that's everything to the left of 5 here, would make it true. Now I can do that with a line like this one. Now be careful because we look at it like this. Okay, you look at the inequality, does it eat the letter? That's all we got to ask. Does it eat the letter? On this case, it does not. If it does not, then the line goes to the left, just like we saw. Okay, but this indicates that everything to the left of 5 on the number line makes this inequality true. 4 would make this true because 4 is less than 5. 0 would make it true because it's less than 5. Any negative value would make this true because they're all less than 5. Again, this indicates that there's an infinite number of values that would make this true. There's too many to show in a list. But if by chance this inequality was eating the other direction, so if it were to eat the x, then the line would go to the right. And another thing you want to keep in mind with these is that it is possible to see these written this way. So you're still comparing x with 5. But see how that inequality is eating the 5? So these two inequalities here that I have, they're exactly the same. They're just shown a little different. So let's go through these 4 examples. And yeah, I don't know what happened to 3, but I also don't care. So on the first one, I got x is less than 4. Now we already got 4 on there, and you could put a 3 and a 5 right there if you wanted. I'll just keep the 4 though. So this first one, it says x is less than 4. Now the first thing we want to do is put the circle on this graph. And this circle is going to be open because 4 would make this false. That statement false, because 4 is not actually less than 4. It's equal to 4, but not less than. So I communicate that on a graph with an open circle. Hey, if you look at this graph, 4 would make this false. Now I see that this inequality is also not eating the x, which means the line goes to the left. Now, some students like to really emphasize that line. I guess mine is kind of color-coded, so you can kind of see the red line, but there's other ways to do it, which I'll show you on the next one, okay? Especially if you're doing this with pencil, sometimes it can kind of blend in with that black line, and then it's kind of confusing when you want to look back at your notes. So let's look at number 2. Let's look at a different way to do this. So we're still comparing x with 4, but this one is saying that x is bigger than 4. X is greater than 4. Which means 4 is not equal to x. It can't be equal to x, so I get an open circle there. Now you see on this one, it's eating the x, so that means that the line will go to the right. Again, some students like to show it like this with kind of a line above the number line. And if that helps you out, then do it, okay? But again, these 2 examples that we just did, they're open circles because they're just less than or greater than. So on number 4 here, x is less than or equal to 4. Yeah, on this one I got the equal part of the inequality, which means at 4, I got to fill that in. That's a closed circle, okay? And this one is not eating the x, which means the line would go to the left. Again, some students like to say, well, look, I'm just going to make this a really thick line and then show that it's going to the left. All right. Again, that doesn't really matter to me, as long as you can see it and understand what's going on, okay? Well, let's compare this then to number 5 here. So on this one, again, it is equal to 4. So it could equal 4, so I'm going to fill in this circle. See, closed circle. Again, that closed circle indicates that it could equal 4. 4 would make this inequality true, even though it's the equal part of the inequality. But this one eats the x. So again, I can show that the line goes to the right on this one. However you want to do it, you can do it like this or just make it a really thick line. It's up to you, as long as it goes to the right. So let's look at the graph on this one. And no need to solve anything on this one, right? We'll see some that do, but not this one. Now on this one, I'm going to put -5 in the middle. And I always like to put my values right in the middle, the one that we're comparing x with directly. In this case, that's the -5. Sorry about the handwriting. But again, I want 3 values, one on the left, one on the right. But this is negative. You got to be careful with the negatives because some students say, hey, look, -4 and -6. But that's false. You can't do that on a number line because, as it turns out, -4 is actually bigger than -5, which means it has to go to the right of -5. And -6 is smaller or less than -5, so it has to go on the left. Okay. Now this one, this inequality, I see that it does not have the equal part of the inequality, which means that I need to put a open circle at -5. Okay, but this one is eating the x, which means that the line will have to go to the right. Boom, that is the graph. Now, as I continue, I think some of you have been told either by elementary teachers or someone else that if you look at the inequality like this one, that the inequality points in the direction that the line should go. This is only true if you keep the x's on the left. But you have to be careful because sometimes, and math people do this on purpose because we're kind of jerks that way, but if you compare x with -5 this way, you see now if you write it like this with x on the right side, it's pointing in the wrong direction. That doesn't mean you can't flip it and switch it to be this inequality because these are exactly the same inequalities, just written differently. So as long as you always keep your x's on the left, that would be true, but you got to be careful. Sometimes the x's are on the right. So that's why we say, does it eat the x? Because if it were in this format, it's eating the x. That means it goes to the right. Let's try this one too. We got x is greater than or equal to 15. So again, I'm going to start with my number line. I'm going to put 15 in the middle, which means 14 would be on the left and 16 on the right. Why is this one different? Because these are positives. So of course, the smaller the positive, the more left it should be, okay? So 15 on this one, yeah, it equals the 15, right? See that we got the equal line with the inequality, which means at 15, we have a closed circle there, right? And then I see also that this one is eating the x. If it eats the x, the line goes to the right. That is all. Yeah, you can hopefully draw your lines more fancy than I do, but that's good. All right, here's a fractional one. And sometimes students get real caught up with these fractional ones. But again, if you're doing it, even if you're doing it by hand, I like to put 4/7 right in the middle, just like we usually would. Some students would say, hey, there's 0 and there's 1 because they know 4/7 is right in between. I like to work with the fractions because it's kind of easy for me to do that in sevenths. So that'd be 3/7 to the left and then 5/7 on the right there, okay? Well, for this one, once again, we got the equal part of the inequality, which means at 4/7 I will have a closed circle. But this one, this inequality is not eating the x, which means the line needs to go to the left. So I did this line a little different, but it's the same thing. All right, now this one will require some principles of equality. Try this one out. Take a minute to try this one out. 5x plus 2 is less than 12. Then we'll take a minute to do it, then we'll go over it. So right here, first off, we got to solve this. So you definitely would not want to start graphing this right now. We need it solved first. Okay, so just like we saw in the bell work, I need to zero out that plus 2 right there by subtracting 2. But if I do it one side, I got to do it both sides. That's the principle of equality that will zero that out as planned, and then it allows me to drop my 5x. Now that's a subtraction principle of equality, which means the less than symbol just can be dropped. Now we got to do 12 minus 2 though, which is 10. That's not too bad. It's going to make this division easy. That's what I need next in order to make that coefficient of x a 1. I want 1x, not 5 x's. So how do you make a 5 a 1? Just divide it by 5. Okay, but if you do it to one side, you got to do it both sides. Now before you just start flipping the inequalities, right? We divided by 5, but it's positive 5 right there that we divided by, so that's not going to affect the less than symbol. Still less than. 10 divided by 5 is 2. All right? So this gives us the inequality that we need to put onto the graph. So I got 2. To the left, I'll have 1, and to the right is 3. But at 2, I would have a open circle because of the less than symbol. It's not equal to 2, just less than. So again, this means that 2 would make this inequality, not just this inequality false, but this one. Okay? Of course, 2 in this inequality would make it equal, but equality is not part of the true statement there. Then I see that this is not eating the x, which means that the line would have to go to the left. Okay. So once again, just so we understand what this line is communicating, all the values to the left of 2, including these decimal and fractional values in between, they make not just this inequality true, but this one. Okay, that's the one we're focusing on. They have to make this inequality true. So everything to the left of 2, like 1, 0, -1, -1,000,000, and so forth. All those values would make this inequality true. Now we got the graph, right? So we got to take the graph and we got to make the inequalities from the graph. The first thing we want to notice on this is that the circle. We want to see the circle, and then we'll determine the direction of the line. I really couldn't care about this line going to the left right now. I just want to see if the circle is at 1. Because this means that I'm comparing x with 1. Okay, so all I've got to do, now that I know I'm comparing x with 1, is put the inequality in between. Well, the first thing I notice on this one is that it is a closed circle, which means that x could equal 1. That would be fine. But then I look and I see that this line is going to the left. Since it goes to the left, the inequality should not eat the x, meaning I should have a less than symbol between the x and 1. That is all. Let's try this one. So once again, I notice on my circle, it's at 2, which means that we would have to be comparing directly x with 2. It's just this one is a open circle, so I do not have the equal part of my inequality. I just see that this line here, yeah, it is going to the left, which indicates that x cannot be eaten by the inequality. It's just x is less than 2. Done. You guys try this one out. Try this one out. Take 30 seconds, try it out, and then we'll go over it. So the first thing I notice on this one, just like the others on this graph, I'm comparing x with 4 because that's where the circle is. Okay, so I see also that this one is a closed circle there, which means that x could equal 4. All right, but then I see that this line is going to the right, which means that the inequality should be eating the x. So I end up with x is greater than or equal to 4. Maybe you want to make yours look better, whatever. That's it. Well, there's our objective. Yeah, the objectives, I guess. I can solve and graph inequalities, and also I can write inequalities from graphs. There you go. It has to go both ways. So not only are we solving, but then graphing and then writing the inequalities from the graphs.